types of aircraft that do different things or operate differently, such as eVTOLs or air taxis, drones, supersonic aircraft, that kind of thing. So I'll just ask our panel members to introduce themselves, starting with Dr. Rashid Ali there.
Hi, Rashid Ali, Coventry University, specialized in flight control, special interest in unmanned systems, both from a design point of view, simulation point of view, and testing point of view.
So I'm Noel Ballot from Safran Data Systems. We are specialized into flight test instrumentation.
Richard White from Lucideon. My background is around materials, so it's the materials end and characterization and testing of those.
Aman Panuu from Sullivan. I'm probably the demand side of things. I'm the most non-technical person on this group. So, but yeah, maybe the customer's voice.
Fantastic, thank you, Aman. Okay, so the first question I'd like to address is it's going to be a brave soul that starts us off. But I thought it'd be useful to define what we're talking about. So the first question is, can we tell the difference between developmental testing and certification testing, and briefly discuss the legislation, the regulations that govern it?
Who wants to take the lead? Do you want to take the lead?
No, definitely.
Well, we need means of compliance and conformance, and that needs to be incepted right at the initial design phases, because sometimes the legislators themselves don't know what the technology it is that we are going to be specifying. So if we get involved, the legislators, at the beginning of the design cycle, then I think you stand a better chance of getting the thing through certification process. If you involve them at a delayed time, then they need to understand the technology that you're trying to develop, the solution that you're trying to develop, and it'll always delay the route to market. So I think the question is working in unison with the legislators with the viewpoint of obtaining the certification in a timely manner, perhaps with operational constraints, which is exactly what the legislators will tell you what the operational constraints are, but at least there will be a solution. Right now, they always view advances in certain types of technology with a little bit of skepticism, and I think rightly so.
Okay, Rashid, I mean, can you explain just briefly the difference between experimental aircraft and the legislation, regulations governing that, as opposed to aircraft that carry passengers and cargo, for example?
Well, again, it goes back from safety issues. We are mandated to prove that we are not to have more than one failure in 10 to the 9 operations. Now, of course, that can only be achieved through rigorous testing. Now, testing means a lot of expense, both in terms of time and in terms of cost. Now, with experimental aircraft, you have a certain, shall we say, lateral, because it is not to be operated with freight or passengers, and it is in a slightly less risky environment. So there's different types of operational models in terms of certification. If you're going to go for full types certification, then it has to basically comply with whatever legislation applies to the aircraft that you're designing, whether it's a CS-23, CS-25, or CS-VLA, depending on the type of aircraft in production. But it's not a straightforward answer. It just depends what is it that you need certifying.
Okay. Noel, perhaps a question for you. How does the equipment and the way that things are tested change when you move from an experimental aircraft to an aircraft that's going to be certified? Is there a lot of difference? Or?
Well, you just need to prove conformance. You need to prove conformance through testing methodology which has been validated against standards. And you've got to basically make sure that it doesn't fail beyond the specified limits. And you've got to address all the failure modes of that equipment. We then have to address the integration issues of that equipment with other equipment as well. So it is a non-trivial task.
But essentially we're using the same sensors and data acquisition equipment in flight test, for example.
Well, what is important is the reliability of the data you are collecting. So definitely the selection of sensors, the selection of data acquisition systems are very important for that process. And this is the reason why, I mean, all the airframe manufacturers, generally speaking, I mean, if they are just doing some validation, or validation is not the right term, but some additional testing, but not related to certification, they can do that with basic equipment. But when they have to go through a certification process, I mean, they need to have qualified equipment and sensors and so on.
I'll give you an example. If you look at a power supply in an aircraft, one of the things that will be mandated that the power supply or any equipment can withstand 4,000 volts for 10 milliseconds. Okay, so that's the spike that a piece of avionics is supposed to withstand. Now, how do you prove that the equipment has had a 4,000 volt spike for 10 milliseconds? So the piece of equipment that is injecting the 4,000 volt spike for 10 milliseconds needs to be validated as well. So we've got to prove that we have been able to produce a 4,000 volt amplitude spike for 10 milliseconds precisely. So everything needs to be qualified, everything needs to be verified, everything needs to be validated against those standards. Unless and until that is proven, then you will not have the certification.
Okay, so, sorry.
You know, I mean, it's just a failure of the data acquisition unit should not interfere with the avionics of the aircraft. This is the kind of thing also you have to be very careful about.
Okay, so if we're talking about new types of aircraft, sorry, Richard, did you want to say something?
No, carry on,
Please.
carry on.
No, I mean, I just...
It was really coming on to that new types of aircraft as
Please.
well. It's whether the rules that are there in place are really fit for purpose for going into very, very different technologies, and how are those built up to an equivalent level and equivalent status within that. Supersonic aircraft are very, very different. There's so much that changes within that system, and it's getting those rules and regulations in place that are fit for purpose, but also don't constrain the industry going forward.
The thing is, when you're looking at the mix of drones coming into the whole thing, you're talking about use cases which are much more diverse and larger in number than what we have been used in our aviation sector generally. Now, the moment that happens, that just makes everyone in the regulator world a bit nervous about it. And that's why what you're seeing is for a while, you started looking at the risk-based approach of, certifying things and all that stuff around that. But now we are slowly moving away again from that. We're looking at each application, performance metrics, etc. But it takes time. It's taken 10 years to reach that journey already, right? And it's probably another 5 to 10 years away before we get those standards in place.
So here's a question following on from that. I mean, do we feel like the aviation, we've got no one from the regulator here, unfortunately, but are they proactive enough? Do they work with the industry enough to help develop these new types of aircraft?
I'm going to be shot down here because I can already see from the smile coming from there and all. But actually, about 10 odd years back when we were talking about regulations, you hardly saw anyone from regulators coming on board actually on a conversation like this also. Like, this is just so happens we don't have. But actually, we are seeing the regulators being much more active than they were a decade ago. Right, so I know in reality, when you go to them, they have a different face probably. But I think they're becoming more open to the challenges the industry is having. And the reason for that is there are different ways of communicating to them that is happening. And that is because the ecosystem is changing very fast. The players who are coming into there are coming with different ways of thinking from cross-sector, etc., bringing in different ideologies to help the regulators kind of understand that problem a bit better. Okay, and I think at the other end, it's also this whole startup unicorn kind of influence that is happening. There is so much money flowing around it is that their bosses are also saying we better act fast. So it's a kind of a, whether it's good or bad, I'm pretty sure there are more stronger views about that. But those are a couple of things.
The political, shall we say, direction is also important, because there is a lot of R&D money flying around, and the political, let's say, vision. If you look at it from an autonomy point of view, the National Technical Committee on Autonomous Systems in the UK, they charted out a fairly long-term roadmap for autonomous operation. And the NTTC were being sort of guided by them. And the government is then going to place certain pots of money for those activities. Now, that's going to spur the industry sector. And of course, if you look at the wider ecosystem, whether it's the financial system, the political system, the social system, everything is being impacted by the technological change. So to boost up the economy, to boost up the morale of people, sometimes the legislators are going to get the push from the politicians saying that, we really need to move this along a little bit. And that's what we basically seen. 722 stayed dormant for almost 8 years, 9 years. There was hardly a line change in that. But all of a sudden, in the last 3 years, the whole raft of changes have been made in 722, basically to accommodate certain type of flight operations. So again, I think political whim has something to do with it as well.
Any other comment on that? Or?
I think I concur with what you are saying. There are many challenges from a financial point of view, from a political point of view, and definitely, I don't want to be pessimistic, but it's still a long way to go. Maybe not 30 years, hopefully, but it will take some time.
Yes, indeed.
So are we talking about regulation being driven by market demand here? Well, because regulation surely should be driven by different things.
It's a tie-in, actually. There are
right.
dependencies here. I won't say market demand as much, because that is a bit misleading itself, right? It's a different question when you get that unicorn mindset into that. It's the monetary kind of vigor that has come behind it that is kind of driving the political will, the industry's will, etc. around that. Demand, what it does is, the demand encourages the industry to innovate more and invest more in R&D, etc., which has a ripple effect in terms of the pace of development that may happen. And as we've seen that increasingly as the relationship with the regulators becomes a bit more closer, you will see that indirectly the regulators will start getting influenced by it. But that's not going to be the only reason for that. And I think if it becomes, then it's going to be very risky.
So let's talk specifically about, what legislation we might need in the future then, if that's, obviously we can't get too specific, but if we were talking about, we'll keep going with air taxis. What kind of legislation can you imagine that we need at the moment that we don't have? Are we covered by some parts of regulations for?
From an operational point of view, vertical separation, horizontal separation. What is going to be the minimum vertical separation required in an urban requirement? What will be the maximum horizontal separation required in an urban environment? What type of urban environment? That is going to vary, because if you go out there across the river and looked at the aerodynamic behavior between buildings, no one's going to be very certain of how the wind is going to play, what is going to be the let's say the transient effects, etc. And small aircraft flying in that environment is risky, to say the least. So again, with an unpredictable environment, without any rules for separation, vertical or horizontal, who's going to provide that separation? Is it going to be the air traffic control, or is it going to be a highfalutin computer somewhere on the ground separating those vehicles? So again, this is a slightly uncertain area we're in. So until those operational requirements are satisfied, things will be difficult. And of course, another thing would be Aman's VTOL is charging on top of a building. I want to come into land, and I tell Aman, please get off the building because I need to land. And he says, sorry, I'm charging my batteries. Where do I go? So how much spare capacity do I need to be able to maintain safety within that operating regime? So there's a lot of uncertainties right now, which I don't think anybody's addressed.
Yeah, I have to say, again, I've said this a few times in various kind of platforms, and all the points you said, and the power example you previously given is, there is much more than just the aircraft to be legislated itself.
Correct.
This is a collaborative sector. I really mean we got to stop saying this is an aviation sector. It's a new aviation sector. You got to have a different mindset. We got to talk about infrastructure legislation. We got to talk about civil, digital. There are so many things. Environmental. Every building probably would require an environmental sensor around that to feed into the route planning system, which is going to say, okay, this will breach the noise threshold of a particular suburb or something where it is going to fly. So there are so many things which still need to be done. And the thing is, and coming to your power example, is the complexity is probably not the aircraft alone here. It's the complexity is how much more you have to legislate to allow the ecosystem to have the resilience to allow this to fly.
We're talking here really about the volume of aircraft, aren't we? In a lot of ways, it's no, is it?
Well,
No, I mean,
everything needs to be safe and everything
Yeah,
has
right.
to work
Even
absolutely
only
spot
one,
on.
but I mean,
even only one of a new type of aircraft
Yeah, right.
wouldn't even.
Absolutely.
Yeah, I mean, something I often hear is that in the future there's going to be lots, as many air taxis possibly as there are cars. I mean, isn't there need a? I mean, am I getting carried away with a hype cycle there, or do we need similar legislation?
That's my
your
job to be hype, right?
Right.
So probably not that much, but a certain percentage of that, yes, it is. Like we assess that you're looking at 50 to 70,000 vehicles that would be required to meet the demand in London alone, right? Okay, but it's yes, that adds to the complexity of it, but I think we're way far away from that. I think by the time we reach 70,000, we would have already time tested many technologies and legislation.
Yeah, but another thing that we've got to look at, is that the only transportation model that we're going to think?
Absolutely.
I mean, for an urban environment, is an air taxi the only, I mean, I call it the eVTOL, but I call it the e-rich technology. It's the toys for the rich boys, right? If you look at the seat mile cost for any of this technology, you can do the sums and it takes you about 5 minutes to work out that it's actually about 4 times more expensive, the R22 per mile. So you're not going to make money out of that.
yeah, 22 is not that expensive also.
Yeah, exactly. So we have to sort of, I
Very good
think,
reference.
look at these things in a little bit more rational way. Let's prove the technology, let's prove our testing methodologies, let's prove our model-based simulation technologies to the point where the certification authorities are inspired with confidence that allows us to then operate in somewhat uncertain environment. Right now, the answer is always going to be no. I mean, I've been working with the Skyfarer project for the last 3 years, in fact, 4 years now, and we are looking at a hybrid drone for medical supplies in Midlands. It's taken us 4 years for them to allow us to operate in the Cranfield Beyond Visual Light Site operation corridor. And we've only managed 3 or 4 flights, and it's taken us 4 years, right? And the amount of infrastructure required just to do beyond visual line of sight set testing is horrendous. Every 100 meters, we have to have a marshal on the ground, which on the walkie-talkie is saying, I've got overhead, I've got him overhead, I've got him overhead, along the entire route. So there's a lot of things that we need to address before we even go close to having air taxis operating in London. One crash on the city of Westminster of a drone, the entire sector will be shut down.
If I'm going to add a bit of optimism to it, actually. I don't want to scare away all the investors and people who are working on it. The thing is, it's taking you longer to get that medical drone certified and be allowed to fly, etc., because you're doing something game-changing. You add a few hundreds of those tests around the world, and then the confidence, the critical mass, once that reaches, you're going to see a leap again happening here. The second point is, it's how fast the pace of technology has evolved over a period that we have seen. So, and we cannot overlook that. And I think this is where I say that we have to kind of not be limited by our aviation thinking. We got to remove our aviation thinking and talk to some other sector. We got to talk to other stakeholders to then form an opinion what that pace may look like. Because you're going to go in and say to your board and say, and that what, I need another 200 million here, and their first thought is going to be, last time I put something in aerospace, I had to come back after 2 years, and you said I need 200 more, right? So do I put that money in there? But you got to convince them at the same time that actually, see the change that has happened. Okay, we are now close to realizing and returning that. So I think
the change is incremental.
It is.
Yeah.
The change is incremental. It's not, we have nothing today and we are going to have air taxis operating in London in 2022. That's not going to happen, unfortunately. Yes, we have to prove the technology incrementally, and we have to build up the safety case and the confidence, both in terms of the legislators and the general public. At the end of the day, it's the general public that is scared of this technology. So we have to educate the masses, we have to educate the educators, we have to educate the legislators. I think there's a massive education that needs to take place right across the sector for all these technologies to be then A, viable, and B, realizable.
Okay, so I'd like to involve the audience as much as possible. I'd say that at this juncture at the moment. So, I mean, if you can think of some great questions, that would take the pressure off of me a little bit. I'm sure there's some great burning questions out there. But first, I'd just like to pick up something that Rashid, something he mentioned, and that was he used the term model-based engineering. Yeah, and it's a term that, and digital twins is a term we've heard a lot in the last couple of days. I mean, undoubtedly, these are tools that are going to be used more and more increasingly in the development of new aircraft. Do current regulations account for that change in the way that we test aircraft, or do we need new regulations to do that? You're nodding your head, Richard. So
I think it's going to be a balance of everything within that. I think there's got to be new regulations around that, but I think critically, again, coming back to the technology and the understanding of that, those models are going to be so complex and the algorithms, but to actually understand what's going on, we'll need somebody almost working alongside those models building up to understand where those constraints are, where the limitations are, where are those sense pressure points within that. And I think that's got to be done in tandem across the whole process. It will take time.
So as systems become more complex, do we need more complex ways of testing them?
We need more complex ways of validating those, but we need better ways that those models can be validated without that test, side-by-side testing. How robust are those digital twin models, and can we put reliance on those? And ultimately, that's where it's got to go forward in my mind.
Well, these digital twins, they need to be a twin. It needs a physical representation, right? That's what we heard today. Yep. Noel, do you sound like you want to say something on this?
No, it's I concur with that. I mean, it's definitely you need to go digital, but also testing, and it's the right combination of both, and the benefit of one bring to the other, and vice versa.
So connect. Sorry, Rashid, do you want to?
Yeah, that's multi-physics models. So instead of just aerodynamic models, we need thermal models, we need structural models, everything integrating into a multi-physics approach rather than a secular approach, which is what we have been doing over the last, say, 15, 20 years, where the aerodynamists are using CFD tools independently of the FEA tools. Now what we need to do is we need to bring the dynamic simulation and stability tools, the aerodynamic tools, the structural tools, all together so that we can look at the modal interaction between the various modes in terms of both failures and in terms of performance. I think that's where we need to be heading.
Okay. So in a way connected to that, I'd just like to introduce the idea of autonomy and autonomous systems. Maybe a bit of a leap. And it's even further in the future, obviously, but it is a new type of aircraft. And we do see autonomous systems in aircraft already. I mean, perhaps someone could talk around the legislation in the regulation that we have and we might need governing those.
Difficult one, really, because first of all, we've got to understand what autonomy is. The models that we know is either fully automatic or fully manual. Autonomous system, we need to build into that system conscience. How do we give computer conscience? So when you look at pure autonomy, if we can embed conscience in a computer system, then yes, we can talk about autonomy. If we can't embed conscience in a computer system or in software, then the best we can talk about is automation. So we are talking about high levels of automation, not autonomy. When we look at certification right now, the certifiers or the legislators will say it needs to be deterministic. Now, by deterministic approach, they mean there are 2 inputs going in, there are 4 outputs coming out. When those 2 inputs change, what happens to those outputs? That is a deterministic approach. If you try to sell a self-tuning PID controller for a pitch attitude control system, they will reject it because they do not know what those constants will be from a self-tuning point of view. So certifying intelligence, yes. Certifying degrees of automation, yes. But certifying an autonomous decision-making ability, which embeds conscience into the thought process, I think it's a big no. That's my personal view.
Rashid, the aircraft, autonomous aircraft itself probably is way, way away, right? Because before we achieve that, we would have to achieve a higher degree of confidence in autonomy within the support systems. Let's say our traffic management, or how a testing mechanism actually works and how we can make it much more faster and more efficient, etc. Right? So in many ways, when you're talking about autonomous, there's a layer of, it's a graduated approach. So by the time we reach where everyone accepts autonomous as the rule, actually you will not have to sell it then. Because by then you would have already proven the support kind of infrastructure and services.
Yeah, but that is still high degree of automation. You can go back to the Sperry autopilot way back in 1918. What it does, it stabilized the aircraft in row. That's what the Sperry autopilot did, which was basically a gyro-based system. So they've automated one axis of the aircraft. Now we have 6 axes of the aircraft being controlled. That is a degree of automation. There's nothing autonomous about an aircraft. You can press the button and it'll go from point A to point B. That is not autonomy. That is automation. So we have high degrees of automation, but no one has, to this day, at least to me, proven an AI system to take an independent decision with conscience. I mean, I always give this example to everyone, and this is something that everybody needs to reflect, that I'm an aircraft on the tarmac. I look outside and I say, it's a nice day to fly. I take off. I see some fire and I see people burning. I say, hell with them, let them burn. I fly away. That's autonomy.
Yeah, I mean, there are different levels of, so in my mind at least, there are different levels of autonomy.
Okay, that's the difference between automation and autonomy.
Yeah.
And I think we need to be very clear in that approach, that we are certifying highly automated aircraft. We're not certifying highly intelligent aircraft. Aircraft are not taking decisions by themselves. They are following very precisely a predetermined course of actions.
Okay, but sorry, Richard, do you want to?
No,
but legislation in itself, does legislation, it creates trust, doesn't it, in systems? You know, that's part of what it does, you know?
So, yeah, even in highly automated systems, we need deterministic approach. I mean, if you look at the DO 278C standards for certifying avionics, airborne avionics, it's exactly the same. They basically have set of inputs, set of outputs, deterministic. If the system can do it, it'll be certified. If not, forget it. That's the legislator's approach right now.
Okay, let's take a slight step back. I mean, is there any areas of regulation right now on a more granular level, perhaps software or a particular part of an aircraft that need to change, do we think, anywhere? Or materials or?
I guess materials is quite a difficult one to put automation into.
Well, yeah.
It's a
perhaps outside of automation.
Fixed part of it, but yeah, certainly how they interact. Yeah, there could be within that. I don't. Yeah.
Okay. All right. Let's talk about innovation a little bit in relation to regulation. I mean, I've often heard that regulation can hold innovation back if it's done incorrectly. I mean, do we think that's the situation at the moment in the aerospace sector, or do we have that situation?
Probably this is where I would contradict myself, and I would say that is one factor of aviation, which is safety comes kind of first, which we should leave as aviation in this. And in that manner, I don't think so. It inhibits innovation, actually drives innovation, because it's asking the industry to think of safety first and still be innovative.
So innovating in a safe way.
Yeah, innovative to be safe.
Innovating to be safe. Yeah. Okay, all right. Any other comments on that, Aaron? No. Okay, all right. So does anyone from the audience have a question perhaps they'd like to pose to the panel?
I'd just like to add something on the discussion we had about the automated and autonomous testing. I'm not sure if you've seen, but Airbus recently, we did the ATOL project, which is automated takeoff and landing. So during those, I think it took 4 years to do that. And when we did that, it is to some level using machine vision. So it recognizes on the runway where the lines are, the middle line as well, and then it does an automated takeoff. And also same thing for landing. So it is using machine learning, right? So that's what I was thinking. You were saying it's no, but I think it's been done already. Probably it's not certified, but I think it's being done. So if you look at the project, and yeah, I think to say that it's really far, I think to me it doesn't sound realistic. I think we've done it. It's just really the question is, how do we certify it? That's a very valid question. But I think it's wrong to say that no one is doing it, because I think we've done it. We've been involved and we've shown that it can be done. I think I've personally worked on a lot of similar algorithms, and that's why yesterday I asked the question about the artificial intelligence. Definitely the challenges are more the certification side of things, because as you said, how do you certify it if you don't fully understand it? What the inputs are, you know, but what the output will be, you don't know. So,
and also, I think, I mean, if you look at Tesla, I mean, if you look at the lane departure control on a Tesla, it's absolutely fantastic. I mean, you can take your hands off, and the thing will not go 6 inches to the left or 6 inches to the right. Yeah. But it really does depend on using a lot of sensors. Yeah. But again, it is not taking any autonomous decision. It is pre-planned. When it sees those lines, it follows the path. So it is guidance control, deterministic guidance control. It can be certified. But when somebody comes along and says there are no lines, or the spacing between the lines has changed, or the width of the lane has changed, or the environment has changed,
I think
it recognize it?
It does to some extent, because it is machine vision, so it's machine learning. So it will, as long as you have lines, you're right. So if you remove the lines, probably, yes, then the system gets confused. But if sort of it takes into account the sort of distancing between the lines and all that, I think it will be able to calculate.
These are all actions which are pre-programmed. These are all actions pre-programmed because we are looking at these things. This is from a software point of view. Is it producing the algorithm by itself?
To some extent, yes, because it is a machine learning algorithm, so it will learn from the...
Again, within the defined constructs.
The thing is, Rashid, if you think about it, it comes to the discussion we were having outside, right? It's the interpretation of the definition of autonomous. Okay. In this case, what we are talking about, you can say everything is going to be rule-based. There is no way we as humans are going to let the machines take over.
Thank you.
That's a fact, right?
I rest my case.
But that doesn't change the definition of autonomous that the regulators may have, and so the industry may have.
We have already agreed the definition of what autonomy is, right? We are talking about highly sophisticated automated systems. Okay? Unless and until you embed conscience, you cannot have autonomy.
Yeah, I think it comes down to that definition, but your point is a good point, right, sir?
Do you think that the civil aviation authorities, do you think they are playing catch-up in this area then? I know it's a question, you're not on the panel, but I'm just curious.
I certainly think, because I've read quite a bit about it, and the sort of first applications for these that went through to EASA was in 2019. And I think we're still waiting in the aerospace industry for them to catch up, as you say. And the roadmap is there. They put a roadmap to say by 2025, they're not saying, yes, we will certify this, but we are looking at ways how we can understand and how we can potentially look at certifying this for the future. Because if we are being realistic, I mean, this is what everyone is working on. It does thing that is amazing. It can be really good, but as you say, we don't know how bad it can be as well. So they are working on it, and I think they are playing catch up. And I think rightly so, because you can't rush into this thing. As you say, it can do amazing things, but bad things can happen.
We're already seeing automatic taxi systems being certified. Yeah. So it is something happening. So, following the yellow line or the white line on the tarmac is being followed on the aircraft and being certified by CA and by EASA. Yeah.
So I think it'll be quicker than we think. It's not going to be that far.
Yeah. And the number one benefit is safety, right?
Absolutely,
yeah. Which is something we're all for.
That's what should drive it, really. Safety. Obviously, if it shouldn't be done as quickly as possible, it should be done as quickly as possible, as long as it's safe.
But I think it goes back to the original question: how much testing, how much simulation, what percentage are we going to accept in testing? What percentage are we going to expect on the physical model and on the model-based testing?
Absolutely.
Unless and until we go to multi-physics models and we can prove the the models to be accurate through physical testing, we're not going to have much reliance on those models. And I think that is the route that we need to take with the CAA, saying a lot of the stuff can be validated on software, on simulation. That's going to cut down on testing time and route to market. And I think that's basically what the industry needs to work on as well.
And I think to add to that, they are very open because they let, if you can, it is public, the Atoll project. If you look, they have allowed us to fly it. So they are open-minded. It's just convincing them that's going to probably take time, and convincing everyone that it's safe, right? Because it's not just them. It's, as you said earlier, the public as well are thinking, so is the plane going to fly on its own? Am I going to trust that or not? So it's a matter of educating everyone, as well as sort of getting the legislators involved as well. So yeah, thank you.
Thank you. Any other questions from the floor? Yes, Pete, you have to wait for the mic, I'm afraid.
Okay, so a couple of questions I'll pose to you. Most aviation accidents, when you look at the root cause, is a human one. Yeah, most major incidents with an aircraft come from a human one, possibly with the exception. This is really the question: what do the panel think about the effects of the 737 MAX scenario on autonomous flight and even the eVTOL market?
Yep, an unbiased question, I hasten to add. Asked from a point of impunity, I think. Does anybody want to take that?
72% are human-based. The other 20%, 28% are the factors. I like the pilot because 28% chance of survival, as far as I'm concerned. He might step in and save me. Should anything go wrong. But when machines go wrong, they do go wrong disastrously. So I can show you hundreds of videos of pilot-induced oscillations resulting to catastrophes and computer algorithms going wrong because you've got blocked air data sensors, or you've got malfunctions in other sensors, which is stabilizing a marginally stable platform. So it's, I don't know, it's a difficult one, but I would still see supervised autonomy or supervised system control for a foreseeable future. We might even go to a one-man cockpit eventually, but at the end of the day, the role of the pilot will be much more than flying. I think he'll be a systems administrator more than a hands-on person who flies the aircraft. But again, high degrees of automation. And the dog. Don't forget the dog. Dogs got to play the vital role in the cockpit. And when somebody says to me, what's the role of the dog? Well, I say the role of the pilot is to feed the dog, and the role of the dog is to bite the pilot if he touches anything.
I think there's a bit of a lesson from the military to take on this one. So when we look at the next generation of battle management systems that are coming in, what they are intending to do is they're intending to bring in various scenarios and data points to the battle commander to then decide what decision they're going to take. And you can look at the pilot in that construct. Everything else around the ecosystem needs to be improved and tested, etc. But and I don't think so. The pilot needs to be in the aircraft itself, but that probably is my own thinking. Okay, I'm pretty sure a lot of you want the pilot there, right about. But as long as there's a human in the loop, and the human in the loop, in today's time of data that is coming, is no way can make an informed decision that quickly. So we have to help him through technology to simplify that decision cycle and shorten that decision cycle. So I think the pilot will always be in the loop, but not necessarily, eventually, not necessarily in the vehicle itself.
But I mean, if you look at the development, a 707 in the 60s had 1,509 gauges, dials, buttons, knobs, and lights, 1,500 plus. Now, if you look at a MFD electronic display, a Garmin 3000 or a 3-tube EFI system, very simple with 1 or 2 primary flight instruments. The flight checks are done by exception rather than by rule. only the things that the pilot needs to check is enunciated. So the cockpit resource management, the CRM aspects are much better what they were 15, 20 years ago. And that's all due to the advances in data, sensors, data fusion. We're making the life of the pilot easier from a flying point of view. I mean, I was flying a few weeks ago a completely manual aircraft. And I tell you what, it's not easy to fly a manual aircraft anymore, you know. Half the time you don't know where the data is coming from. So you rely more on the electronics and the systems these days.
I mean, we should say that this, sorry, Richard, I was going to say the 737 MAX incidents were obviously devastating in you know, lots of ways. If nothing else, the loss of human life, which is obviously tragic, but there is a legacy that lives on. I guess that's what the question's talking about, but please continue.
What I was going to say is really coming back to that and saying, yes, it's not human error, but actually there's embedded human error within that system and process that led to it. So it's an underestimation, perhaps, of the control of the system or the complexity of what could happen. It's the scenarios within there. And I think it's looking at those and robustly looking at those as to how wide one needs to go and can go within those.
Which is a process the industry has gone through. And Boeing, as you know, as well.
Yeah.
Are there any other comments on that, or exhausted? I mean, if you could imagine that happening to a new type of aircraft, obviously that's the situation that we're talking about here, and it would be, you know, that's what you want to avoid. Are there any other questions from the floor? No? Okay. I mean, I'm quite happy to wrap up there ahead of time. There's no reason why we have to fill the entire hour. At least not in my mind. I might get told off afterwards, but it's fine by me. It's the last session. So, I mean, I've learned a lot over the last 2 days. It's been very exciting for me personally to see the level of interest and stuff that I write about all the time, meet people that I've only ever met before over email and on Teams and stuff. So it's been a great couple of days to me. I hope everyone else has enjoyed it and found some value out of it. So I thank everybody again for attending and the sponsors for making it happen and the team for working so hard to make it happen. And I close the conference.
And
now.
then how to communicate face to face. We'd almost forgotten.
Yeah, right, exactly. It has been almost 2 years.
I think it's the first conference in almost 2.5 years. And we've basically been sat behind computer monitors, expressionless. You might as well be talking to walls, you know. So this is a good opportunity to actually enjoy that face-to-face experience, which is quite useful.
I should have asked, sorry, if anybody else has got any concluding remarks. That's slightly rude of me, taking the centre stage there like I
I
have.
think you've done an excellent job.
Okay, thank you.
Thank you for organizing such an event. I mean,
You're welcome. Thank you, guys.
Thank you.